In this lesson, we're going to look at how to use natural logarithms to solve real-life problems. So let's look at this example. The mass g grams of a radioactive sample after t years is given by the formula g equals 100e to the power negative 2t. First part of the question says, what was the initial mass of the radioactive sample? So if we're looking for the initial mass, then no years will have passed. So really what we have to do is substitute 0 as t up here and then work out what g is in terms of grams. So let t equal 0 and sub 0 in here instead of the t. So negative 2 times nothing is just going to go to 0 basically. So you're going to get 100 times e to the 0. Now anything to the power 0 is 1, so this will turn into 100 times 1, which is just 100 grams. So the initial mass of the radioactive sample was 100 grams at time 0. Part B of the question says, find the half-life of the radioactive sample. Now the half-life is the amount of time the substance takes to degenerate into half its original size. So if we think about this, in this formula here, we're trying to work out t, and we want g to be half the initial mass. Now if we're saying the initial mass is 100 grams, then half of that would be 50. So the half-life is the time when g is equal to 50 grams, the time it takes for g to get to 50 grams. So we can substitute that in. All we've done here is we've used this formula, but we've subbed g in to be 50. If I then rearrange it to work out t, I've solved the problem. So the first thing I want to do here is I want to get rid of this 100, this multiple of 100. And to do that, we divide 50 by 100 and you're going to get 0.5. I've just swapped sides because I want my subject on this side, it's easier to work with. So e to the power negative 2t is 0.5. We're then going to put into practice what we learnt in the last lesson. If you take natural log of both sides here, then you'll do the inverse operation of e to the power of. So that will bring the negative 2t down. So we're going to take natural logs of both sides. So e to the power of and natural log are the inverse operations. So that will take us down to negative 2t. And we can type this into our calculator. If we hit the ln button 0.5, that comes out to be this, negative 0.693, and so on. If I then divide through by negative 2, I get 0.347 years. So the half-life of the radioactive substance is 0.347 years. I wouldn't leave it like that because you wouldn't use that. You wouldn't tell somebody that something happened in 0.347 years. You would really want to work in days. So if you multiply that with the number of days in a year, 365, you'll get roughly 126.5 days.